Good evening, Bronx Middle School 7th grade scholars. If you guys thought you would be enjoying your Sunday night, you are correct. If you're watching this all the way through, you will be one step closer to passing your finals. A step closer than you were if you were not watching this. Now, 5-10 minutes ago, I was watching the New England Patriots play the Eagles, and I was screaming my lungs out. That's my team, New England. I was screaming, you guys are better than this. Edelman, catch your ball. I was so disappointed because I know they are the best team in the NFL, and they're letting themselves beat themselves, and it's really frustrating right now. They're down about 1 point going into the half, and I know they're better than that. And to be honest, it got me thinking, you guys, I was really disappointed this last math session review that we had. I honestly thought you guys were 100% ready for the math final, but I kind of second-guessed myself. So this video, hopefully you guys watch it all the way through. And yeah, you go ahead and let's be number one again, like I know you guys can. You guys have showed me some magic in the classroom. I want that to come out during the exams. So do your best. Don't overthink it. Stick to the basics. And that's what this video is going to be about. It's going to be about the basics. Now, to talk about what the exam is going to show, I wrote everything down. So what we learned in Unit 1A, we had the concept of proportionality from graphs, ratio tables, equations. We did unit rates, scaling, and why certain graphs or equations were not proportional. Unit 1B, we did circles, scale drawing from the scale, the picture, to real life. We talked about who's faster or not running on a track. We also did scale factors for, regular lengths and scale factor for area. And then we also talked about which scale, which map was bigger or not. And then finally, to wrap it up, for the second unit, Unit 2, we talked about commission, bank interest, expressions and equations, percent error, and tip and tax. So, without any further, let's get started with this review. All right. Very first one. Yes, I bought this just for tonight. As soon as the game stopped, I went to Walmart, got this to teach you guys. Let's do it. All right. Constant of proportionality. Now, I'm going to draw a graph. I'm going to label my graph, all my points. Now, to find the constant of proportionality on a graph, I want you guys to pause the video, take a look at this graph. It starts at 0, 2. Let me know what the constant of proportionality is. If you said there is no constant of proportionality, you're right. It doesn't start at the origin. Now, next graph. Starts at the origin. Pause the video, find the constant of proportionality. If you said there's no constant of proportionality, you're right. It's not a straight line. The two things that make graphs proportional enough for you to find the constant of proportionality, it has to go through the origin. It has to be a linear graph. I bought an eraser too. Let me use it. That's a terrible eraser. Now, and I'll draw some points for you guys. I have 2 points on here. This one right here is 1, 2. This point right here is 2, 4. Pause the video. Find the constant of proportionality. If you said the constant of proportionality is 1 over 2, you're wrong. Now, as discussed from our review, the constant of proportionality is the same as far as ratio table and graphs. You're taking the right side divided by the left side, the output divided by the input, or how I like to think about it, you're just taking the y value divided by the x value. So in this case, our y value over here is 2 divided by 1. The COP is 2 for this graph. The y value divided by the x value. Now, if we were to put this into a ratio table, well, we already have 1, 2. We have 2, 4. Pause the video, give me 2 more points. Here we go. 3, 6. 4, 8. As we can see, the constant of proportionality is whatever you multiply one value by to get the next. So 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. That constant stays the same, and it keeps it proportional. It keeps the ratios the same, going all the way down. Right? Pick any point. Let's do 3 and 6. The y divided by the x, the right side divided by the left, is going to give you a constant of proportionality of 2. Woo! All right, Patriots just scored. I'm happy. Nice. Edelman with the score. I love it. All right, back to this. Back to this. This is more important. Now, how do we write the equation for this? Pause the video, write the equation for this graph. All right, we're back. Now, a lot of you, let's use this point right here. Let's use 3 and 6. A lot of you will be tempted to do this. (3x equals 6y). If you test your equation, remember, when you guys write any equation, I don't care what it is, you test your equations. If we test this, we're going to see it's not going to work because of the reversal error. And this is what I mean by test it. Pick any other point. It could be the same point. Let's use the same point. 3 for x, 6 for y. If we plug in 3 for x, and 6 for y, we're going to see this equation makes no sense. 3 times 3 is not 6 times 6. So you fell for the reversal error. I know it's tempting to do that. 1x equals 2y. No, that's a reversal error. Your equation is not going to work. Flip it. Instead of 3x, 3y equals 6x. Now test it. We plug in y. 3 times 6 is 6 times 3. That's the associative property. It works. We can plug in the first point. Plug in 1 for x, 2 for y. 3 times 2 is 6 times 1. 6 equals 6. It works. Do not fall for the reversal error when you write your equations. Easiest way to check it, pick any point. Test your equations. You guys must. That's a non-negotiable. Test your equations. Whatever equation you write, test it. All right. That being said, looking at this equation, we know that the COP is 2. We know that because it comes from here and here. How do we get the constant of proportionality from an equation? Try to get it from here. Pause the video. Go. Yes, you get y alone. To get a constant of proportionality from an equation, isolate the y. We see a 3 by the y, we divide both sides by 3. Over here, we got the y alone. Over here, we got 6 over 3 x. Here's the COP. The COP is what's by the X value. Remember, the constant of proportionality is the thing we multiply X by to get Y. That's why we're getting Y alone. We're multiplying X by a certain number to get Y. Again, you're multiplying X by 2 to get Y. X by 2 to get Y. Over here, 6 over 3 is 2. We're multiplying X by 2 to get Y. Now, I'm going to give you another one. Try to get it on your own. Now, I'm going to make up 3 random ones. A graph, a ratio table, and an equation. You guys are going to tell me which one has the best constant of proportionality. Highest constant of proportionality. Here's the graph. The point on the graph is 3, 1. Now for the ratio table. Last but not least, the equation. Let me think about this one. Now, you have your 3 things. Pause the video, find the constant of proportionality for each of those 3. Go. Now, let's do it together. They almost got an interception. I was about to scream out of my seat. All right. For here, again, constant of proportionality, Y divided by X. The Y value is 1. The X value is 3. 1/3. Over here, Y divided by X. The right side divided by the left side. Let's use the easy number. Five divided by 10, simplify that, you get 1/2. Last but not least, equation, you get Y alone. Two over 8 is the same thing as 1 over 4. Let me rewrite it. Now we have the 3 constant of proportionalities. 1/3, 1/2, 1/4. Which one is the greatest constant of proportionality? Bingo! All right, now, if you're having a difficult time getting Y alone, so it's really hard to divide the numbers and simplify or whatever, remember that the equation, this would be the, oh, I messed up. The number in front of the Y is the A value. The number in front of the X is the B value. And the COP is Y over X or B over A. But that's a little difficult. What I would do, just to not be confused, is get Y alone. If not, take it back to the basics. Remember, AY equals BX. The number in front of the Y is A. The number in front of the X is B. And from the ratio table, this column is A. That column is B. Nice. All right, what's next? Unit rates. All right, for unit rates, I went and found some, I don't know, coupons that came in the mail. I have one from Acme. I think it's pronounced Acme, Acme, Asemi, I don't know. Aldi and ShopRite. All right, let's take a look at it. Let's start with here. All right, I see sweet potatoes. Sweet potatoes here are 59 cents a pound. Let me write that down. Now, let's look at the other one. Oh! Here we go. Next one. How much are sweet potatoes at ShopRite? Sweet potatoes. $2.49 for a 5-pound bag. And that is, what is this? ShopRite. $2.49. 5 pounds. Now, you want to find out which store is giving you the best deal. So, you have to get the unit rate, right? Luckily for us, Aldi, it's already at the unit rate. The unit rate is getting one of the variables to equal 1. That's it. In this case, we're talking about money and pounds. Over here for Aldi, it already tells us it's 59 cents a pound. We already got the unit rate for Aldi. Now let's go over here. $2.49 for 5 pounds. How do we get the unit rate? Get the pounds to 1. Let's just divide by 5. Now, you guys are in 7th grade now. No one is going to hold your hand. Numbers are going to get unfriendly. You guys have to do the math the best you can. I don't care if you multiply up, if you know how to do long division. Do the math the best you can. And again, in this situation, to be honest, instead of dividing $2.49 by 5, I can multiply this by 5. If I multiply this by 5, I'm going to get about somewhere a little, so 50 cents times 5. Oh, hold on. Punt? Are you kidding me? Whatever. But 50 cents times 5 pounds, you're going to know you're already at $2.50. So you know it's going to be greater than this. So you know your answer there. But we're not going to shy out of this. We're going to do $2.49 divided by 5. We'll do it the 2 ways. We'll do a long division, and then also we'll do multiply up. We can do multiply up first. All right, let's see. Wrong side. All right, so 5. Now, I'm going to pretend $2.49. Let's change it to $2.49. And when we're done, obviously we're going to divide by 100 to get back to our answer. So, 249 divided by 5. The closest you can get to it is what, like 200? Well, you could get more than that, but let's use 200, and then I'll show you guys what I'm doing. So, 5 times what gets me closer to 200? 40. 5 times 4 is 20, and then the other 0. Now we have 49 left. Now, to get to 40, we can multiply by 8. Now we have 9 left. Closest we can get to 9, we have 1. Now we have 4 left, right? Yes. Now we have 4 left. Now, remember, to get to 40, it was 8. So, to get to 4, we do 0.8. Bingo, we have a 249. Add it all up. 49.8. We have 49.8 as our answer, but remember, We multiply it by 100 so it could be friendlier. So now we have to divide this by 100. So our unit rate is going to be 0.498. And now, as we can see, we're going to get a better deal at ShopRite. At ShopRite, it's 49.8 cents. I froze there. I was like, what? 49 cents and what? What's under a cent? A millicent? I don't know. A hundredth of a cent? 49 cents and 800ths of a cent. But as we can see, it's less than the 59 cents. So you're getting a better deal at ShopRite. Now for the long division, we're going to do the same thing. 249 divided by 5. Now, again, we'll take a shortcut this time. We knew that to get 200, we multiply by 40, right? And then after that, to get 40, we multiply by 8. So let's multiply by 48. 5 times 48 will give us the 240. What do we have remaining? We have 9 remaining. Times 1 would give us the 5. We have 4 remaining. Now, we can't multiply, we can't have any more 5s into 4. So our total is 49, and the leftover is 4 out of 5. So our answer, we have 49 holes that go into 249, and the leftover is 4 out of 5. So our answer is 49 and 4/5, or 49.8. Remember, we did 249, but we want 2.49. So we have to divide it by 100. And our answer is 0.498. We got the same answer. That's long division for those who know how to do long division. I highly recommend that way. To me, I don't know, multiplying up is it's a little annoying, but whatever you got to do to get to the answer, if you're getting there consistently, keep multiplying up. All right, let's see what's next. Next up, scaling. All right. As far as scaling, I have a little story for you guys. I want to relate this to real life so it makes sense, like the why behind what we're doing. Everything you're learning in math is going to be real skills that you apply in real life. And I'm going to give you a story. So my sister, not too long ago, about a month ago, she got married, and she wanted to have an event at our house. She wanted to use the upstairs and the basement, but our basement, the walls they weren't too pretty. They were supposed to be white, but this one's okay. It's not that bad, but it had like lines and like handprints and like dirt on the wall. So we had to clean the walls. So I decided to just paint the wall. And to paint the wall, I went to Walmart. I went to get like gallons of paint, and I specifically remember this number. The gallon of paint cost like $12.48. But then I asked myself, how much is that gallon? How much of the wall is it going to cover? So I did some calculations. Our wall was 1,620 square feet. 1 gallon of paint was covered 400 square feet from what I Googled. So I had to figure out how many gallons of paint I needed to cover the entire wall. Again, these are skills you're going to need as an adult. So luckily, you guys know how to do this. You know how to scale. Put this in a ratio table. You have your gallons, and you have your square feet. We know that 1 gallon of paint covers 400 square feet. Now, let me know how many gallons of paint I'm going to need. Pause the video. Go. If you got 5 or more than 4, you're correct. Because if we look at it, we need to get to 1620, right? If we multiply both sides by 4 gallons of paint is 1,600 square feet. It really annoyed me that I needed like a very little over 4. So I was asking myself, should I get, they also had a 5-gallon bucket. Would it be worth to get the 5-gallon bucket or get that extra gallon of paint, just use a little and then like store it later? So I told myself, let me just see like which one I get the best deal from. So let's switch gears. Now that we know how to scale, let's see which one I got the best deal from. All right, next up, I'm gonna create a working station downstairs. I'm gonna bolt this up and then get like a tripod to hold that so it's easier. All right, let's see. So they had a 5-gallon bucket that was $59.59. Sorry, 99 cents. Again, you're not gonna get friendly numbers in real life. You're not gonna go to a store and buy something for $20. No, it's gonna be $19.99. You're not gonna buy something for $15. It's gonna be $14.95. You're not gonna buy something for $100. It's gonna be $98.47. You're not gonna get friendly numbers. You gotta be able to do the math so you can figure out how much you have to pay or how much you have to take to the store. All right, now, so let's do this. 1 gallon was $12.84. So I had to figure out, am I saving money by buying the 5-gallon bucket? What are we gonna do? Scale. $1 gallon is $12.84. We're trying to get to 5 gallons. Just multiply by 5. 5 gallons, and then this, do it to the side. $12.84 times 5. Wow, that's gonna, I should probably do that up. Let's do that over here. All right, 5 times 4, 20. We have a 0. 5 times 8, 40. We have 2 zeros. 5 times 2 is 10. We have 3 zeros. 5 times 1 is 5. Add it all up, 0. We have 2. We have 4. We have 6. 2 decimal places. Now, however you do it, I don't know how you guys do it. I know a lot of people do it like this. A lot of people split it up. You do 5 times 12. Then you do 5 times 8. Then you do 5 times 4. That's fine. However you do it, make sure you get to it consistently. Did we get intercepted? Come on, come on. That's not a catch. No, 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 no. That's not a catch. That's not a catch. Come on. I'm sorry. All right, but the answer should have been $64.20. Now you have to ask yourself, okay, for the 5-gallon bucket, you're paying $59.99. For 5 of them, you're paying $64.20. Clearly, you're gonna buy the 5-gallon because it's cheaper. But then remember, here's where you have to ask yourself: is the money you're saving worth it? So this is what I mean by that. If I would have bought the 5-gallon bucket, I would have like dumped it out, and from like a whole 5-gallon bucket, I would have had like this much left. You know what I mean? Like storing that's kind of But then if I would have bought 5 of the 1 gallons, I would have completely used 4. The last gallon, I would have used a little bit of it. Get where I'm going with this? So a lot of people, if they think of it from that sense, they want to get the 5 single gallons so that the last bucket is like small, you're storing something small. But then some people want to save this $4.21, which is exactly what I did because I like to save money. So I bought the 5-gallon. That's exactly what I went with. Now we're going to do another scaling problem that I literally did. Watch this. All right, so I got the painting material. I got downstairs. I started painting the wall. Let's see, how big was that wall? Hold on. There it was, 216 square feet. So, I wanted to sleep in 3 hours. Legit. I bought the stuff. I brought it all downstairs. I knew I wanted to go to sleep in 3 hours. I started painting the wall, and a little section of it, 216 square feet of it, took me 10 minutes. I asked myself, am I going to finish painting in time? If not, I need to call my brother to come and help me or something like that. So I literally took out my calculator and I started doing what? Scaling. Yes. Now, remember, my wall was 1,620 square feet. That's the space that I was painting. Now, ask yourselves, am I gonna have enough? Am I gonna finish before I want to go to sleep? So am I gonna finish in 3 hours? So let's scale it. Let's find out. Pause this video. Start to scale. Now, let's start scaling. Let's see what happens. What I would do in this situation is just ask myself, how many 10-minute blocks? Well, you could do one of two things. You can go to the unit rate here and then multiply by the amount of minutes in 3 hours, right? Let's do that first and then see, like, am I gonna need that? Or you could go to the unit rate here and multiply it to 1620. Let's try all the different avenues. If we go to the unit rate here, it's 1. And since we divide by 10, we divide this by 10. 21.6. How many minutes are in 3 hours? Correct me if I'm wrong, but it should be 1,800, right? 1,800. Wow, 180. So we're going to have to multiply that by 180. All right. 0. Start doing it. 8 times 6 should get 48. Hold on. Come on, what's the score? Get back. Oh my gosh. All right, we have 2 zeros, we have 8, we have 3 zeros, we have 16. Over here, we have 2 zeros, we have 6, we have 3 zeros, we have 1, we have 4 zeros, and we have 2. Adding it all up, we have 0, we have 8, we have 12, we have 8, and we have 3. Now, in 3 hours, it's going to be more than enough space. So, let's see how long it was supposed to take me. Let's scale up to the 1620. Really quick, I would get up to maybe 1,000 first. So 2 times what? 2 times 5 should get me close to 1,000. Let's do that. We have 50 minutes, and we have 216. For the sake of time, because I'm going to save some time with you guys watching the video, I'm going to start doing this math on Wolfram, but I want you guys to be doing the math. My gosh, this shirt is annoying. All right, so we have 1080. Now, we need about close to 600 more. We know it's not going to be by 3 because that's going to be greater than 600, so let's multiply by 2. That's going to be 20 minutes. That's going to be 432. So that's going to be 1,500 and something. So that's 7. It looks like we need maybe a half of that. This is going to be 5. This is going to be 108. And then bingo, I think that's it. Let's see. That's going to be 10. That's going to be 12. There's the 12. And then that's the one up here. That's going to be the 16. Yep. 16, 20. This is going to be 75. So it took me 70. Well, theoretically, if I kept going at that same pace, it would have taken me 75 minutes to complete that wall. So yes, I would have had enough time to sleep. And to be honest, that's exactly what I did. And I did finish before 3 hours, and I got enough time to sleep. All right, let's see. What's next? Equations, equations, equations. We can use this, actually. Okay, let's say ten minutes was 216 square feet. X is going to be my minutes. Y, let's put feet. Y is going to be my feet. Again, you guys are tempted to do this. 10x is 216y. It's wrong. Reversal error. Reversal error. Test your equations. Reversal error. Don't fall for it. Flip it. Test your equations. Plug in x and y. Y is 216. 10 times 216 is 216 times 10. Test your equations. How do you get the constant in proportionality? Pause the video. Get y alone. To get y alone, there's a 10 right by the y. 10 times y divided by 10. Y is 21.6x. What's the constant in proportionality? Boom! 21.6. Now you know that for every minute, I'm going to paint 21.6 feet. That's what this says, right? X is every minute. Every minute, we multiply the minutes times 21.6 to get how many square feet of my wall I painted. Every minute times 21.6 is how many square feet of my wall I painted. Remember, 10 minutes was 216. We plug in 10 for the X. 10 times 21.6 is 216. So for every minute, I paint 21.6 square feet of my wall. All right, what's next? Proportionality. This is the last thing that pops up in unit 1A. I'm going to write this down. You guys are going to tell me which equations are proportional, which ones are not. And then I'm going to check if that camera is still going and I'm not talking to myself right now. All right, let me write them down. Y is 3x. Three y is 5x. Last one. All right, now, take your time, look at these, let me know which ones are proportional or not. Let's see. Oh no, Brady was sacked. The video's still going, but oh my gosh, there's a glare. Oh well. What was that? Oh, it almost picked off. 4th and 17? Oh my gosh. Wallet you. Now we're going to have to punt. At least we're up 7. That's good. All right. If you chose this as the one that's not proportional, bingo, you're right. This little +3 over there It's messing up our flow. It's messing up the proportionality. Now we can test that. This one, what's the constant of proportionality? 3. This one, what's the constant of proportionality? 5/3. This one, what's the constant of proportionality? We can't find it. This 3 is messing up our flow. Let's put it in a ratio table so I can prove to you guys that there's no constant of proportionality with that. Let's pick random x values. 1, 2, and 3. If we plug in 1 for x, we get 3 times 1, which is 3, plus 3, it's 6. If we plug in 2, we get 3 times 2, which is 6, plus 3 is 9. If we plug in 3, 3 times 3 is 9, plus 3 is 12. Now, over here, you multiply 1 by 6. Over here, you multiply 2 times 9/2, which is 4.5. That's not the same. Over here, 3 times 4. That's not the same. COP here, 6, 4.5, and 4. They're not the same. This equation is not proportional because this plus 3 is messing up our flow. That's it for Unit 1A. If you completely understood every single one of that, you are more than ready for the Unit 1A portion of this exam. Let's go to Unit 1B. This one is going to be fairly quick. I'm going to try to make this video in under an hour. I think I use maybe about like 40 minutes. So the next 20 minutes, I'm going to spend 10 and 10 on Unit 1B and Unit 2. Now, 1B, we did circles, we did scale factors. So, circles. Area of the circle. Be careful. A lot of you guys want to use this equation, r squared times pi. That's fine, but I caught a student multiplying the radius by 2. That is not what that means. Radius squared means the radius times itself, the radius times the radius. Radius to the power of 3 means the radius times the radius times the radius. The powers tell you how many times you multiply a variable by itself or a number by itself. So, instead of using this equation, try this. To be honest, I would use that. Radius times pi. So you don't get into that misconception with r squared being r times 2. Cut that misconception out. I don't want to see it. If you don't understand what the powers mean, r to the second power, stick to this equation. Radius times pi, you will not go wrong. All right, next one, circumference. What's circumference? Diameter times pi. Or, I saw a lot of kids put their thumbs down for this when a scholar said this. 2 times the radius times pi. Pause the video. Why are those two equations the same? Bingo. 2 times the radius is the diameter. So those two equations are the same. Last one. Diameter, just like we said, is 2 times the radius. Now, let's talk about the constant of proportionality. For the first one, the constant of proportionality between no, that one's hard. Let's go to circumference. The constant of proportionality between the circumference and the diameter, what is it? Pi. Constant of proportionality between the diameter and the radius, what is it? 2. Remember from the equations, isolate your variable. The number by the other variable is your constant of proportionality. So in this case, we get diameter alone. 2 is by the radius, that's a constant of proportionality. Over here, we got circumference alone. Pi is by the diameter, that's the constant of proportionality. So constant of proportionality here is 3.14. Yep. Over here, it's 2. Trick question, what about over here? What's the constant of proportionality between circumference and radius? 6.28, because the number by the radius is 2 times pi. All right. Next up, yes, distance around a track. Let's say I was running on a circular track, and the radius of that track was 10. What is the distance that I ran around a track with a radius of 10 feet? Pause the video, solve the problem. Come on, interception. No, don't let him run. Man. All right. If you got the circumference, you're right, because you're running around the perimeter, right? Which is circumference. Circumference is the diameter times pi, and we know that the diameter is 20 feet, because it's twice the radius. 20 pi. If it says leave it in terms of pi, that's your answer, 20 pi. If it doesn't say leave it in terms of pi, use 3.14. Right? Oops. There we go. What else? Oh, who is running faster? Okay, this one, there was a misconception on here. Let's say one person is running on a circular track with a radius of 10. How far did they run if they run one lap? 20 pi. This person, how far did they run? 22 pi. Who ran further in one lap? This person. He had the bigger track and field. Now, if I told you guys, sorry about that. If I told you guys who ran faster if they ran in the same amount of time. So, let's put these into numbers. Let's see what 22 pi is. Now, this person went 63 feet. This person went 69 feet. Who ran faster if they both ran at the same time? Let's say they both ran that lap in 3 minutes. This person, if you think about it, let's say you're racing your best friend. Your best friend has a head start. But when you start running and you get to the finish line, you get there at the same time. You ran faster because you ran longer. Your best friend had the head start. You had to catch up. You were booking it. You ran longer. Sorry about that. You ran the same time, but you ran further. You ran the furthest distance. Because you guys ran at the same time, you ran further. I keep saying that. You ran faster. So who's faster in the same amount of time? The person who had the longest distance. Another misconception. When I told you guys to find how far you ran around a track, a lot of you want to find the area. You're running the perimeter of the circle, the perimeter. You're not running like this. You're not running like that. No, that's the area. Stop finding the area. You're running the perimeter. You're not running the area. It makes no sense. The area is the space inside of an object. The perimeter is the length around the outside. You're running the length around the outside. You're not running the space of the circle. All right, what's next? I feel like that took longer than 10 minutes. Scale factor. All right, let's do scale factor of 6 and 12. Now, the scale factor is how much times bigger one thing is than the other. If we look at here, we have, so let's say this was A and B. All right, scale factor from this shape to this shape, it got 2 times bigger. The radius went from 6 to 12. Scale factor from B to A, it got 2 times smaller. You're multiplying 12 times 1/2 to get 6. That's the scale factor for the radius. Now, be very careful when it asks you for the scale factor for area. Actually find the area because you're going to see it's different. In this case, the scale factor is 2, but the scale factor for the area is going to be 4. It's going to be, when you get the scale factor of area, it's the normal scale factor squared. So if your scale factor was 3, scale factor of area is 9. If your scale factor is 4, scale factor of area is 16, and so on. But don't be lazy and use that. Find the area. I'm confused as to why in the past a question would ask for the scale factor of the area and you guys would use the radius. It makes no sense. It's asking for area. Why are you using radius? Hold on. Yes, first down. Bingo. All right. Get the area. Now let's do it. Scale factor of the area is the scale factor squared. So, over here to find the area, radius times pi. The radius is 6. 6 times 6 is 36. 36 pi. Over here, radius is 12. 12 times 12 is 144. 144 pi. Now you will see from 36 to get to 144, you multiply times 4. So the scale factor grew by 4 times. See how it changed? The radius grew 2 times, but the area grew 4 times. Bingo. When it says to find the scale factor of area, actually find the area and then look at the scale factor. All right, whew, that's it for 1B. I think I went over that 10-minute mark. If I had to guess, that's like 15 or another 20 minutes. I think we might be in an hour. Nice run. Why is he mad? He just ran like 15 yards. We're in the 4th quarter. We're up 7. We're in the enemy territory. We're going to score. All right, test 2. This is like good karma. Me doing this video, now the Patriots are winning. I love it. Nice. No. All right. Test 2. Let's start with commission. Okay. Here's a good story of commission. When you guys think of commission, just always think of me. Say, hey, Mr. Collier, let's say I'm working at Foot Locker, right? I'm working at Foot Locker. And remember, when you guys get actual jobs, you're going to see there's a couple of ways to pay people. The most common way is an hourly wage. If I'm making $10 an hour, if I work 5 hours, I made $50. That's hourly wage. That's how much they're going to give me. Or a lot of other places do commission based on what you sell. So I work at Foot Locker. If I sold $1,000 worth of stuff, that 1,000 is the store's. That's not mine. I sold it for them. They're going to give me a percentage of what I sold. That is commission. It's like a tip. I'm going to tip you for selling this much for me. You're going to get a percentage of what you sold. So commission is a percent of what you sell. So if my commission was 10%, if I sold $1,000, I'm going to get $100. If I sold $2,000, I'm going to get $200. The more you sell, the more commission you make. It's a percentage of what you make. Now, let's find it. let's say oh no, who got injured? Don't be Edelman. Okay, good. Whew. I thought Edelman got hurt. Let's say 12%. Now, another thing we should bring up is identifying what the hole is. So, if your commission is 12% and your sales were $2,000, how do you do that? We're trying to find out how much money you're going to make on commission, right? That sale of $2,000 is your 100%. 12% of that is what you're going to get. What you get is the part. That $2,000 is your whole. Now, we're trying to scale to what? The 12%. So, use your benchmarks. Benchmarks. 5, 10, 50, 25. Use your benchmarks. Go down to your easier numbers to get to the number you're trying to get to. If it's too hard, go down to the unit rate. For this one, actually, I want to go down to the unit rate instead of the benchmarks. Trick statement. Unit rate is a benchmark. Divide by 100. Bingo. Unit rate, 1%, $20. Now we're trying to get to 12 multiplied by 12. Boom. I sold $2,000 worth of stuff. Foot Locker is going to pay me $240. That's my commission. That's how much I'm taking home. I'm taking a percentage of what I sold. That store is getting the $2,000. Of the $2,000, they're giving me $240. Good job. Bingo. Now, let's say you got paid, I don't know, $300. How much did you sell? Now, you got paid $300. $300 wasn't the whole. What you sold was the whole. So that $300 is your 12%. Scale to your 100%. Use your benchmarks. Again, what I would do is go down to the unit rate. But if you guys know of an easier way, do it. Another easier way is scaling down to 2, then multiplying by 50. Because if you scale to 2, dividing this by 6 is pretty easy. It should be like 50 or whatever. But I like unit rates. Stick to the unit rates. Divide by 12. You get 1. Divide by 12. You should get like 25, I think. Do that on the side. More practice with long division. 12 times 2 is 24. 12 times 20 is 240. You have 60 left. What? When did we punt? Whatever. But 12 times what is 65? 25 was our answer. $300 divided by 12, 25. Our unit rate, $25 for every 1%. Now we're trying to scale up to our 100%. Multiply by 100. I sold $2,500. They paid me $300. Come on, pick it off. That's it. Identify the hole, and these are going to be super easy. Pick that off. Man, That touched your hands. Ugh. All right, next. Yeah, so you got to be able to work forwards and backwards. Forwards, they give you the sale, find the commission. Backwards, they tell you how much you made, find out how much you sold. Now, next one, bank interest. When it comes to interest, you can earn interest or you can be charged interest. So interest, a good way to think about interest is like a savings account in a bank. Savings account, you earn money. So the bank pays you for having money in your savings account. Every month, they pay you a certain percentage. And then also, you can be charged interest. Let's say you were late on your credit card payment. Let's say the interest rate on your credit card payment is 25% or whatever. They're going to charge you for being late, or they're going to charge you every month for having a balance. That's interest. You can either earn interest or you can be charged interest. There's a difference. One is a markup, one is taken away. Now, let's talk about the markup, the interest that you earn. Let's see. What do I have here? Let's say you deposit $5,000 into your bank account. Interest rate is, what did I put? Hopefully I put 10%. Yes, I did. Interest rate is 10% and it's every 6 months. How much money are you going to get in 1.5 years? Again, these numbers are never going to be friendly. Stop being so used to friendly numbers. They're going to be unfriendly. Now, you deposit $5,000. The interest rate is 10% every 6 months. You're trying to find out how much money you're going to have in 1.5 years. Now, first thing you have to ask yourself is, how many 6 months period are in 1.5 years? 3. You have 6 months, a full year, 1 year and 6 months. That's 1.5 years. You have three months. So you start off with the 5,000. Let's label it. You're gonna have 6 months. After that, actually, this is too big. Hold on. Pause this and solve this on your own and then come back. Bingo. Now, a misconception that you need to get out of your head right now. We've been dealing with new holes for forever. Get used to the concept of a new hole. There's three periods, right? Your money's going to grow 3 times. It's not 30%. You're not scaling from 100% to 130%. No, you're scaling 10% 3 times. So your $5,000, first is your 100%. We're trying to scale to 110%. That we know how to do, right? We don't need to go through the math. We know that 10% of this is what? $500. So add it together, it should be $5,500. Now the next year, that $5,500 is your new hole. Now, we're trying to scale to 110% again. 10% of this is 550. So you should get 6,050. You do that math on your own time. Now, finally, this is 6 months. That's how much money you have in 1 year. Now it's going to grow one more time for 1.5 years. That's your 100%. 10% of that is $605. So that's going to go to $6,655. Let me double check that. I think I started off with 1,000, 5,000. 5,000 times 1.1 to the third power, and we get, yes, 6655. Good. Correct. Now, this is if the problem is being nice to you and they want you to work forwards. So you start off with your 5,000. What are we doing? Oh my gosh. You start off with your 5,000. You grow 3 times. 1.5 years, there's 3 6-month periods. They're being nice to you. You're going forwards 3 times. You guys know how to do that. 100% scale to 100%. 110%. 100% scale to 110%. 100% scale to 110%. They're not going to be that nice. Now, come on. What if they told you that we'll use 5,000? Hold on, let me make sure it's an easy number to calculate. No, that is a horrendous number to calculate. Let's see. Okay, we'll do that. Let's say after the 1.5 years, after the 1.5 years, you have $4,000. You need to find the original deposit. So this is different. This is harder. This is what I would ask you guys. In 1.5 years, you have $4,000. The interest rate was 10%. How much money did you deposit? Now, instead of being nice and going forwards, you have to work backwards. Remember, we always started with 100%, went to the 110%. 100%, 110, blah, 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 blah. That's how much you ended with. At the end of that 18-month period, that $4,000 was your 110%. Something grew to get to $4,000. So you need to scale down to the 100%. Let me do that for you guys. Oh, I don't like this. I don't like this at all. Whatever, it's never going to be friendly. But it should be 36.36. Let's keep it at 36.36. Now, you're working backwards. That 36.36 is your new 110%. Scale down to your 100% now. You get 33.05. Oh, I used the wrong number. Hold on. I did something else. All right, I messed up. This was supposed to be 53.24. Now we can do that. Now, if you remember, when we started off with our 5,000, you had to grow your money 3 times. So you made the 5,000 100%, grew to 110%. That is your new 100%, grow to 110%. Then that is your new 100%, grow to 110%. Now they're telling you, after 1.5 years, your money grew to 5,324. Find the original deposit. So in this case, that 53.24 was your 110%. Let's see how much that is. $48.40. So, $48.40 grew 10% to get $53.24. Now, you need to go back 1 more year. You get 4,400. And then finally, 1 more year. and your original deposit was $4,000. To test that, go forwards. So what this is saying is you deposited $4,000. After 6 months, 4,000 grew to 4,400. After 6 months again, it grew to 4,840. And then finally, after 1 year and a half, your 6 months, your ending balance was 5,324. That's how you work backwards. Working forwards, you guys all know how to do it. Start practicing with working backwards. That's how much you ended with. Some number grew 10% to get that. And then some number grew 10% to get that. And then some number grew 10% to get that. Did we get a safety? Did we get a safety? No. Don't be flag. No. Man. All right, whatever. Let me not pay attention to that. So that's banked interest. Good. We have 2 more things to work on, and then we're done. I think we're using a lot of time here. All right. Next 2 things is going to be expressions. And then after that, we're going to combine, markup and discount. You know what? All right, this game is getting interesting, and we have a lot of time tomorrow. So here's what's gonna happen. With the expressions tomorrow, I'm going to give you guys a do now, and if you're watching this video, it tells me that you'll be prepared for tomorrow. This is what the do now is going to be. You're gonna write me an expression for 10% increase. Sorry about that, take it back. 10% decrease, 6.625% increase, and then a combination of the both. Let me write them on the board, and then whoever's paying attention to this video, I know you watched the complete video, so you're ready for tomorrow. You're gonna write me 3 expressions. %10 decrease. 6.625% increase, and then both combined. And here's the reasoning behind this do now. I wanted to show you guys how money works like in real life. So what I did was I went through my mail, I looked for a coupon. I found a 10% off coupon for Burlington Coat Factory. I had to go donate a coat. So I donated a coat and I got 10% off. I bought something for $24.99 and I got 10% off, and I also had to pay tax. The tax in New Jersey is 6.625%. So the do now for tomorrow is going to be you guys writing me an expression, not an equation, an expression. So let's say the variable is X. An expression using X that shows 1, 10% decrease, 2, 6.625% increase, and then last but not least, putting those 2 together. And then when you guys do that do now, our mini lesson is going to be finding out how much I actually paid for the item I bought. The item I bought, again, was $24.99. The mini lesson was going to be finding out how much I paid for that item. And then that's going to wrap everything together. You guys would have watched this entire video. You would have seen unit 1A, 1B, a lot of 2. And then finally tomorrow, to bring it all together, you guys are going to do the do now with the expressions and the mini lesson, finding out how much I paid. And I got that right here. So if you're watching this video, you got a head start. And also I got a big surprise for you guys. Right now, I don't know if I could do it yet. I gotta ask Mr. Hall. But I'm thinking of giving the person that impresses me the most on the final a big present. I'm thinking maybe a brand new Chromebook. I know a lot of you guys, you don't take care of your Chromebooks, and it's actually embarrassing. Like, your Chromebooks just look really bad. So I'm thinking of actually getting you guys a great gift like that. Maybe like a Chromebook. Just as like a reward for like the hard work you guys have been putting in this. I know a lot of you guys have been working hard. I want you all to be working hard. So by impress me the most, I don't mean like 100%. I mean the person who meets all the non-negotiables on the test. Your work is just remarkable, and I've seen like the hard work you put into it. So impress me for this final, and one or maybe two of you might win a great gift to go into the holiday season. So that's it for the video. Hopefully you guys study, and let's see who's prepared tomorrow for the do now, and who knows what the gift is. You never know, the exit ticket might be, what gift is Mr. Collier trying to give away? Answer, Chromebook. At the moment. I gotta ask Mr. Hall if I'm allowed to do that. All right.